Hello everyone, my name is Ray. If you're new to my channel, I do a lot of different projects, a lot of which are wood turning. And that has generated quite a bit of interest and questions regarding my homemade lathe. What you see here is a mold that I made for spinning a Captain America shield. If you're interested in that, there's a video on my channel that goes through the process. There will be a part 2 to that. But for right now, I'm going to stop the video, take this off, and we will discuss all the particulars of the lathe.
I had to stand as far away as I could so that I could get the entire lathe in the frame. So I'm at the other end of the shop. As I approach it, you will see, as far as scale is concerned, it'll change quite dramatically. So the lathe weighs, I think, somewhere between 900 and 1,000 pounds. I don't know for sure because I haven't actually weighed it, but based on the weight of the individual components and the difficulty I had putting them in, I think that is a pretty fair assumption as far as weight is concerned. So let's get a little closer and we will discuss some of the particulars, especially about the motor and spindle. This is the business end of the lathe, the spindle, which has generated quite a bit of questions. How big is it? What size are the threads, bearings, etc., etc. So I'm going to answer this question first. The spindle is made from 2" by 1" DOM tubing. That's the 2" portion that goes through the bearings. The thread is 1.5" 8", and as you can see, my hand for reference, it isn't a little spindle. I actually wanted to go bigger, but 1.5" 8" is a very good size for finding face plates and accessories and chucks of all sorts that are made for wood turning, but also older metal turning and metal lathes use this thread. So it opens up the possibility of finding accessories inexpensively and abundantly. As you can see, these are sizable Rexnord bearings. The mounting plate is 1/2". The bolts that actually hold the bearings onto the plate are 3/4 of an inch, and they're actually tapped into the plate. These are lag bolts that are about 6 inches long that go all the way through. And what you don't see is that there are 2 more underneath this bearing. The bottom of the bearing housing is hollow and it has just enough space for the heads of these bolts to fit underneath. So there are 4 on this end, there are 4 on the other end, and I have 3 more, as you can see there, going down through the central beam that connects the front and rear frames together. This here is a magnetic pickup. This is a magnet, and as the spindle is spinning, the magnet goes past the pickup, and in some of the videos you'll see there's a little red flashing light. If I turn it on here, there it is. So every time the magnet goes by, it calculates the speed between the magnet pickups. So it's constantly calculating the speed. And with this, because it's only registering from one point on this magnet right here, the speed can fluctuate slightly with any slight deviation in the spindle, for example, when it's under load while you're cutting. So is it the most accurate? It is not. However, it's accurate within 2 or 3 RPM, and you only really notice anything when you are under load. So is it important? It isn't. It just gives me a rough idea of where I am within 2 RPM. I don't think accuracy more than that is necessary. Up next will be the motor. Before we get into the drivetrain of the lathe, I'd like to discuss the motor mounting system. The plate that the motor and transmission, you can see the transmission beyond, mount to is a 1/2" steel plate that has all the necessary mounting holes, including these little socket head cap screws you can see right there that actually bolt it to these arms. These arms are front and back that support the motor and transmission together. Those rails that go side to side, as you can see them both front and back, are held on through these slotted plates, as you can see there. If we take a look from the side, they are mounted to the lathe through the bolts that hold the mending plates to the frame. As you can see, they are slotted there. The slots are pretty obvious. This is to adjust the tension on the belt. And right now the belt at its lowest position is when it's tight. So we have a little bit of adjustment up and down, and you can see that is the clearance to the frame of the machine. So it's a system that works quite well as far as stability and support. The only little hiccup is because the plate, rails, and motor and transmission combined are quite heavy, probably about 150 pounds. It is difficult to maneuver it by yourself. So what I use is I put a jack right on the floor, and I can jack it up and down as needed to adjust belt tension. It is only an issue when putting the belt on the first time, or any replacement belts. It's something that is not going to be encountered often, but when it requires the use of a jack. One of the other more common questions is, what motor do you have in that lathe, and how powerful is it? Well, the motor is only 1.5 horses, and as you can see, it is located directly below the spindle. That is a very common orientation, relationship between the spindle and the motor. However, the reality is that where the motor is located doesn't really matter. In my case, it's just made for a more compact design, considering that the footprint of the lathe is so wide. We will go and take a look from the side. This is the heart of the lathe. It is surprisingly a small motor. Most people that ask about it are surprised that it is so small. It is only 1.5 horses. I know that the fashion now is to build a lathe with 3 and 5 horsepower, but the reality is, for the purpose and the way that this particular lathe was built, 1.5 is more than plenty. I have yet to install this motor. So we have the main drive motor, you can see here, which is 1.5 horses. In front of it is a Shimpo variable speed adjustable transmission. So it is actually what they call a cone drive. If you're interested in looking that up, it's a cone drive transmission. This is an older model that came off of a medical grade treadmill. I picked it up for $100, very inexpensive, only because I didn't know I could use it, and I negotiated it for $100. These usually go between $1,500 to $2,000, so it was a good buy. Works great for my lathe, and it's more torque than I actually need. The motor as you can see, it's coupled by a 56C face, and it outputs on the other side. This little transmission produces anywhere between 50 to 250 inch-pounds of torque, much more than the motor by itself can produce, which is why I didn't need a 3 or 5 horsepower motor. So when it's running in the low RPMs, it's about 250 pounds of torque. When it's running in the high RPMs, which is 1,000 is max, is 50 inch-pounds. So pretty good there. This here is a 1/20th horsepower motor with a gearbox, and you can actually see this little chain and sprocket. Let me get in a little closer. So the way this transmission is controlled, to change the speed, normally there's a knob right here, and that knob you would manually turn to change the speed of the lathe only when the motor is running. I got lucky when I got this one. It already came with this gear motor attached to it to remotely affect the speed of the gearbox. So the only thing I had to do, which is on the other side, and that's what this little strap is holding, is add a capacitor. And I had to wire the capacitor so that I can run this motor in both directions. So not a big deal, but you can see there's the chain. It's a little chain, and the sprocket on the gearbox. Let's see here. You can actually see that it also has a sprocket on it. These little red boxes up here, if I can get, there you go. That little red box is a micro switch. There's one over there and there's one over here. There's a finger you can see right there. This sends a signal to my box. It lets me know when I'm at each extreme of speed. So when I'm approaching 0, it triggers a light. And when I'm approaching 1,000 RPM, it triggers a light. and that lets me know that I'm very close to exceeding the mechanical capability of that transmission and stop shy of damaging it. Another common question that I'm asked is, how big is the footprint of your lathe? Being that it is an unconventional design, as you can see there, the footprint often raises a very interesting question. So to answer that, it is 40 inches front to back. That is in that direction along the length of that channel. I'm sorry, the length of that angle, front to back, 40 inches. Width-wise, it is 53 inches. So it is quite substantial. And that adds to the fact that this is an extremely stable lathe. I've had quite large, unbalanced off-center pieces on here, and there is no wobble, there is no shake, there is no shimmy. The lathe doesn't wander all over the floor. It is having the widest footprint possible, obviously within reason, gives you the greatest stability. So you can make out that on this angle, by the way, the thickness of that angle is 3/8. So it's a 4 along the floor there, 4 inches. Vertically it is 6 inches. The thickness is 3/8 of an inch. You can see there are leveling feet on all 4 corners. The attachment of these angles are by 1/2 inch plates. You can see there's one in the front and there's one in the back. The timbers are 4x6s, and you can see right there that it sandwiches, the mounting plates sandwich the timbers and the mending plates. Those mending plates are 1/4 inch. So it is quite a substantial assembly, and it is in the front and in the back the same way. So getting the accuracy of those plates welded together with the frame was critical. You might also notice that there is a lag bolt. That lag bolt, if we look to the side here, pins the joint of the members together. Every joint is pinned with a lag bolt. Some of them are concealed under plates or behind plates or in spots that are not readily visible, but every joint is pinned. That was necessary during the construction. Once the mending plates are in place, as you can see there, those are 1/2 inch bolts with lock nuts holding it together. Once the mending plates are in place, the pin of that lag bolt becomes unnecessary. However, there is no reason to remove it, so it simply stayed in place. Another aspect of the lathe that has generated quite a bit of interest is the tool rest. As you can see, it is an articulated arm into which that the tool rest is attached. This is a bit of a hybrid between several of the different tool rests I found during the research phase. The Moulthrop lathe, HomeMade lathe tool rest, which was a big beam. The Vicmark aftermarket outboard tool rest that you can purchase from Vicmark directly. Very similar, although not nearly as robust. And the stock tool rest that comes with the VB36. I did like the VB36 rest a lot. I did not like how it was mounted directly beneath the headstock, so it would require a reduction in the capacity of the lathe. So this is a bit of a hybrid between those 3 different designs. If we take a closer look, you will find that the rails that are bolted to the frames are 3/4 of an inch thick steel by 4 inches wide. These top and bottom plates, the first link arm of the tool rest, is also 3/4 by 4 inch steel. What you don't see is on the bottom. Let's see if we can see it. Those are carriage bolts that go all the way up. There is a square notch that matches the carriage bolts so that you don't have to worry about spinning the bolts when you turn the handles. The square hole holds them right in place. The second arm, the second link arm, as we can see here, you can see that it has been modified from the original. and you can see that it has been cut. There's a weld there that actually bridges both halves together. And these are stiffener bars, top and bottom on both sides. Together, this is about 2 inches thick of steel. The original second link arm was quite a bit longer, and it turned out that it was too long. It flexed under load. It flexed way too much under load. About an inch or so, which was quite dangerous. I limped through one project, the cherry bowl, the 18-inch cherry bowl. You can see a video of that if you're interested in my channel. I limped through that project, and immediately after it was done, I had to redesign this. So I shortened it by about 2/3. It is quite a bit shorter, but I have not lost any capacity as a result. The foot, as you can see here, is a single solid rod about 1 inch thick that has a hollow tube in which it goes into, and the adjustable locking collar is welded to it. It turns out that it does not need to be adjustable. Once I've set it in place, I've never had to mess with it. It is not a bad feature to have, but it is completely unnecessary. I have, in the year or so that I've been using the lathe, I have yet to adjust that. The I had 2 previous foot designs that I will put pictures of so you can see what they were. One was a locking foot, and the other one was a welded steel 3-pad leg, and that was a disaster. That was actually worse than the amount of flex that I had in the arm originally. If we move up, you will find that this is welded together, 2 pieces of tubing. That is out of necessity. The tubing that I had were 2 different pieces. I did not have one that was long enough to use, so I simply put a pin. There is a pin inside there on both sides that actually connect the two and maintain a strong straight joint. Again, I had it lying around, so I used it, but a single tube would have been fine. I didn't need to spend the money on buying a single tube when I already had these 2. The tool rest, it is a one-way tool rest. It is the biggest tool rest that I could find available commercially. Like I said, one way out of Canada. It's 18 inches long. The shaft on it, the post is 1.5 inches in diameter. This is a shaft locking collar. It's actually only welded on one side, the opposite side. And this handle, as you can see here, turning it will loosen it and let you adjust this up and down. Very, very nice. I love this design. Works incredibly well. Last but not least are the controls. You might think that that might be the simplest thing, but if you've ever had to build a lathe or even any piece of machinery, you will find that the controls are actually some of the more complicated bits. Getting something to run is quite easy. Controlling it is another story altogether. So this control has actually generated a bit of controversy, because most individuals with modern lathes prefer their setup of having a remote control panel with a safety switch and big buttons and all of the bells and whistles, which I agree are nice features. I think that those are nice modern features. However, this is not a commercial product. I'm the only one who's going to be using it. No one else is going to be using it. I am very familiar with it. And as a result, I don't need to have all of those other fancy features because I am intimately familiar with this machine. These features are very nice. In particular, they're very useful when you are selling a machine on the open market. This particular machine won't ever see that. So for me and the way I built this lathe, I believe that these controls work for me very well. I've been using them for over a year, and I think that they have worked fantastically for the way I turn and what I like. So what we have here is, you can see in the front the way that the tool rest beam, for lack of another word, is mounted. The articulated tool rest is mounted to the beam. You will see that the bolts in the back match, and in fact all the legs were drilled identically front and back, and that is to allow for future expansion. If I wanted to put a bed on this lathe, I certainly could. By putting rails front and back on the back legs and extending a bed through them. So for the moment I don't have a bed, and I don't plan one anytime soon. The control is mounted through those very holes. Now that is a 1/2 inch steel plate welded to this piece of 2x2 square tubing. And you can see this here is the power cable coming in. The lathe is powered on 220 single phase. The electrical for the machine runs down through that tube, and you can see it exiting at the bottom. There are actually two covers there. One is for the motor wiring, the other is for the controls wiring, and that allows me to control it forward and reverse and all of the other features. You'll see that in a second. So this is the control panel. It is quite a simple design. The box I didn't make. I had it lying around the shop, and I said, you know what? It's a stainless steel box for something else that never got used, and I decided this is a perfect time to use it. So these rivets you see here, we will see what they do in a moment when I turn the box around. They control the bus bars. So this is the main power to the lathe. This controls all the power for all the components. This is the motor on and off. This is forward and reverse. This is power speeds up and speeds down. Now this switch is wired into the motor directly, so I can only change the speed while the motor is running. This here is the light that tells me if I've exceeded or I am approaching. It comes on just before I approach by about 50 or 60 RPM the mechanical limit of the transmission. So it's a very useful feature to have. The LED display is powered separately because it is on a 9-volt battery. Instead of putting a power transformer, you can see if I turn this around, this is a lock for swiveling the box. It has a 9-volt battery compartment, so I don't have to worry about having a separate transformer to wire in. I went the easy way and just did a little compartment on the side. So turning the lathe on, this is main power. This is motor. You can see its speed is holding within 2 or 3 RPM there. You can see her running. The sound you hear is the motor. The motor always runs at full speed. We do not adjust the speed of the motor. We only adjust the speed of the transmission. And you can see the magnetic pickup there. That is what's reading the speed on the LED panel. So to control the speed is right here. I'm going to, if you look at the chain on the motor below, you can see as I am winding it down, winding it down, winding it down, winding it up. That switch controls that little motor, and I can change the speed in the transmission that way. To verify that that's actually happening, I'm going to power it up, wind it up, and it's on a momentary switch, so it doesn't stay on. Just bump it and it comes back down. I bring it down, and let's bring it down a ways. We can see it's 200, 140. Let's get a little closer and we'll see. There it is. So as we approach, you can see the lathe is actually still running. It is still within the mechanical limits. We're at 22 RPM. Don't want to go too much further than that, even though we can hit 0. But that gives me the warning that I've approached the lower end mechanical limit. If I speed it up, I'm outside of the danger zone, and the same is true on the other end. We're not going to wind it up that far, it's not necessary. But that gives you an idea of how it works. Let's shut it off. That's just motor power, and you will see that it will not run unless that power is on the motor. That is a safety feature to prevent damaging the transmission. Main power off. Having 2 switches is quite handy. It allows me a moment between throwing this switch and throwing this switch. I will sometimes catch a potential issue, a potential problem. The amount of time that this allows me to think is invaluable. And if I had to do it all again, I would have put this switch on the other side. Having it a little further away would have given me that much more time. It has come in handy probably about 2 times. Nothing that would have been disastrous, but it did allow me a few extra moments to think before I threw the second switch, and it actually was beneficial. So if we turn this box around, the pivot, as you can see, it's not locked right now. Once it's locked, you cannot turn the box. So unlock this. It's very handy to set it at a certain angle. The controls, as you can see in the upper right, are the bus bars. I have there's the power coming from the main power switch to the bus bars. Top one is 110, second one is 110, the third one is neutral, and the fourth one is ground. All the wiring for the switches, including the forward and reverse, which was a little tricky. You can see the light, the micro switch for the LED panel itself, and the interior of that box that holds the 9-volt battery. All in all, the wiring was probably, as you can see, I need to make a cover plate. I still haven't gotten around to that. It's been a year. We can't rush these things. Give it another year or so. I'll make a panel cover for that, and I'll have to put a hole in for the magnetic pickup. So you can see that's wired into that. Maybe I'll get around to it at some point, but hopefully I'll get around to it at some point. Well, that's the controls.